Hacking implementations really feels great. For one, most developers aren't really that knowledgeable of the APIs of other third-party services, and that leads to mistakes where developers assume that certain actions are safe, or certain input is definitely trusted, but actually an attacker can turn it into user input by being a little bit knowledgeable with the third-party service. The second thing is that when you do find a misconfiguration in this implementation, you can scan it for other bug bounty programs, and then hopefully you can turn the small payout in one program into a number of different bounties across a number of different programs, which can be great as a nice little paycheck. Today, I'll be looking at the implementation of Google Drive and some of the vulnerabilities that can arise when certain developers assume that parts of the Google Drive API are safe and trusted input. Right, let's just start with the high-level explanation though. So what is a Drive API usually used for by these platforms? Well, obviously the first thing is downloading files. So fetching files from the API, downloading them locally, and then allowing users to download it from the website directly. The reason a lot of websites do this is because in Google Drive, you tend to need permissions to access certain files. So say if I have a file on my account and I want to share it, Google is pretty strict about allowing people to access that file. So instead, what a lot of companies do is they have the file downloaded directly into their own servers, and then from their servers, they allow anyone to download the file. Now, this is just a way to basically bypass that kind of Google permission nonsense. Another thing that they tend to do is to show a preview of the file. So if you ever have like a chat box, what will often happen is that you'll send like a Google Drive link into the box, and then you'll see like, if it's like a PDF, you'll see like the first page of like the Google document or something come up, right? That's nice, it's a good user experience, but it also does require the Google Drive API. So each time you do that, the server will have to send like an API request to the Google Drive to actually fetch that preview. And it also tends to be downloaded onto the server. Another thing which a lot of people actually forget about is listing files for a user. So when you go to actually say upload your file, what will often happen is there'll be like a file picker that comes up. That also requires the Google Drive API. So what the website has to do is they have to send and request to this endpoint, which lists all the files for that user, and then it'll display that information natively in its own UI. So all of these things require the Google Drive API. There's probably more uses, and it depends on what platform you're attacking. However, these are the main three that tend to have most of the vulnerabilities. And this is the endpoint that is most used by these services, and it's just the endpoint that actually gets information about the file. So it uses the Google API's endpoint, Drive, and this is version 3. There is a version 2 which is slightly different, and some companies actually use version 2 instead of version 3. However, at this point, version 3 has been pretty much accepted as a standard, I believe, and most companies will use the version 3 instead of version 2. And we have this file ID parameter, which is just the file ID and it controls what file we get back, and fields. So in the Google API, you have this fields box, which just tells you which tells the server what information the actual requesting server is expecting. So you can put like ID here, you can put name. You can also put an asterisk here. So you can also put an asterisk here instead of actual names. So you specify like ID, like name, like thumbnail or something. But here, if you put an asterisk, it will return every bit of data for you. So that's something to remember as well. And then in terms of authentication, let me just zoom in a little bit more. In terms of authentication, Google tends to use, well, no, it doesn't it uses OAuth. So it uses OAuth 2, which is pretty secure in terms of Google. You can hack the implementation as well of that. However, I won't be going that much into it just because OAuth hacking is a big topic which I'll be looking at later probably. But you have this bearer token which gets returned to you by Google, and this tends to be server side, and yeah, it's just OAuth implementation. There used to be an API key you could specify, like an access token, but I don't think that's really available anymore. Most websites will use OAuth now for this. And this file parameter is generally what we're going to be attacking because it's more often than not user input. It's more often than not going to be user controlled. So when you're uploading a file, this file ID is what they're going to be looking for. Sometimes a company will actually have you place the entire Google Drive URL. So you'll have like https / like drive.google.com, and then you'll have like an actual like drive view file. The thing to remember is that the website has to extract the file ID from that. So that is not a valid way to fetch a Google Drive file via the API. It needs to actually extract the file ID from it. So remember that. That's a way to actually smuggle some of our payloads in, because the website usually has to use regex to extract it, which can lead to being able to put like path traversal payloads into it and stuff like that. And URL encoding or like Unicode characters are very nice at doing this. So whenever you have a drive.google.com link and it gets turned into one of these like Google Drive files that you'll see on the website, you remember that the website has to extract the file ID from the actual link, and it can't just use the link. So that's an important thing to remember. And then the bearer token. Now sometimes this bearer token is user input. If there's like an older implementation, there's like access tokens being used. I have seen vulnerabilities where you can inject things into this token when it is actually being user input, when it is treated as user input. So something that comes to mind is like SSRF injection. So if you injected like a new line character, so something like this, like a \r\n type sequence. If you do manage to inject that, you could do some like HTTP splitting, so request splitting, and then do some like pipelining, which could make the server request things that it didn't expect to, and also lead to server-side request forgery. This is just a little bit rarer now because this bearer token tends to not be user input anymore. And this file ID parameter, you could try CRLF injection on it as well, but it's less likely just because this is in a path, whereas if this is in a header, it's usually weaker. It's usually more likely to have a CRLF injection in here than in the fetch parameter, is because frameworks tend to secure this more. And yeah, that's what the endpoint will look like for fetching the Google Drive file. And this is usually the response from the server. So it'll be like a JSON, it'll be a JSON response. Mostly, I think you can also have like other response types, but the JSON is just the default one. And this isn't obviously the whole response because the whole response is massive. However, these are the main things that I've seen servers look for over hacking Google Drive implementations, which is the ID parameter, which I'm pretty sure is pretty standard. Sometimes the server will verify if this exists to make sure the response came out properly. The name of the file, which is sometimes used, sometimes this is user input, sometimes it is actually used in the API as well. So this is like how the server will store it in a database. This web content view and this web view link are used for displaying the file on the client side. So what you can do is attach this into an iframe, and then what will happen is Google will display the file and allow like people to edit it, do like a small editor. The issue with these two is that again you need to have permissions to access the file for this to work. So if you have like the web view link, if you iframe the file with the web view link and the person doesn't have permissions, you'll get an error, which you'll see in a minute actually in my implementation. ThumbnailLink is a link to download a preview of the file, so that like first page part of the PDF. Not all files have this. If it's a file which is like a bytes file, or it's like a JSON file, like a text file, then it won't have a thumbnail link in it. If it's something like a PDF, a Google document file, I think a PowerPoint also has one, or an image, then it'll have this thumbnail link in it. And then this size parameter, which tells you the actual like size or the amount of bytes in the file. Sometimes servers will prevent you from uploading files which have a certain size in it. So they'll prevent files that have like 20 gigabytes in it or something. There's like a limit. Or if you upload this file, then it'll like display the size next to the file when you try and download it. So these are generally the things that the server is looking for from the JSON response. And if you want the whole JSON string, it's here. You can just find it on the Google Drive page, and you go into references, and then you go files and overview. And this is everything that you can have from it. But generally, most implementations will not be looking at most of this because it's not relevant. Maybe some like description as well. Modified created time sometimes is used as well. So some things here, it will depend on what service you're hacking, but these are the things that I've seen most often. And this is where the exploit comes in, right? So remember that JSON response is going to be important. And then think about this now. So this parameter is alt is equal to media. And whenever you're fetching this URL here, so this endpoint, you can append it onto the query parameters. And what this will do is instead of giving you that metadata, so instead of giving you this JSON response, it'll give you the raw bytes content of the file. So remember, when you fetch the file, you don't get the contents of the file, you get the metadata of the file by default, unless you specify this parameter. So this alt is equal to media parameter. The server will return the contents, and it will return the contents in the same content type as the file extension is set up. So if it's like a text file, it'll return text/plain. If it's a JSON file, it'll return application/JSON. And we can inject that into basically this files endpoint, and this is how we download the file. So if the server is downloading the file, it's most likely going to be using this alt is equal to media parameter. But this leads us into a very technical exploit, a very important exploit here for Google Drive implementations, which is the following, right? If we can inject the alt is equal to media parameter into the file ID, and we create a JSON file that mimics the Google API response, what we can do is actually poison this response. So what we're essentially doing is this response here is what the server expects to see when it fetches the Google Drive endpoint. So when it fetches this. But if we manage to inject via some like URL encoded parameters into here, if we manage to inject our own alt is equal to media here, this parameter here, Google will return the contents of the file, which the server doesn't expect. If the contents happen to be in JSON, the server will return the contents in application/JSON content type. And what can happen is the server will interpret that as the actual legitimate response from Google, when in reality it's a file that we control. Then what we can do is the server, thinking that these files are all coming from Google, so these contents are all coming from Google, that they're all going to be safe, when it tries to fetch some of these files, we can actually redirect it to either our own malicious domains, we can place payloads in here for cross-site scripting, or for example with a ThumbnailLink, we can redirect the server to internal IP addresses and get server-side request forgery. And this is particularly sensitive because the server will more often than not actually show us the response for this, particularly for something like the ThumbnailLink, which is going to be displayed on the page. If the server doesn't verify the MIME type, so if it doesn't verify that it's a PNG, then we can just download this directly off the server and we can get a full read server-side request forgery, which is more often than not a critical vulnerability. So that's most exploits will look like this, where it's all about injecting this alt is equal to media parameter. Oops. Where it's all about injecting this alt is equal to media parameter into the file ID or some kind of other parameter that's being appended into the URL. The only other exploit that I really know of is this CRLF injection here into this bearer token, which can lead you to doing basically the same thing, just differently. And yeah, that's the main thing that we want to focus on. And I'm going to show you that now in the live example, where I look at getting cross-site scripting on the website, as well as server-side request forgery. This is my Google Drive application here, which I'm going to showcase the vulnerabilities that I talked about. Now, as much as I would love to allow you to follow along with this example here, unfortunately, I don't think I'd be able to publish this app on Google. So you need to publish a Google application to get credentials. And I don't think I would be able to get this verified by Google. So I don't think I'll be able to make this example. As well as that, generally, this is going to require your Google credentials to work because it's going to need to access Google Drive on your behalf. And if I stored your credentials on this dodgy PHP server, you'd probably get hacked, to be honest. So it's better off if I just show you this example. Apologies for the lack of a live tutorial could follow along with, but yeah, it's kind of hard to showcase this one. Anyway, so just going to click this connect with Google Drive button, and I'm going to connect with this test Gmail account here, which is my bug bounty test. So we're going to go here, say, yeah, it hasn't verified, but we're going to say continue. And now we're going to have a look at this. Right, so I'm going to finish the OAuth flow, and you can see I've been testing some of these already. So I've done a bit of testing of this, and here's the Google Drive that I'm looking at. So as you can see, we have injection.json and purify.json here. Let's just do the normal flow first. So we need to grab the file ID. The way you usually, the easiest way to grab the file ID, if you're wondering, is to just go here, copy the share link, paste it in your browser, and this right here will be the file ID. Remember when I talked about when some of these websites use this drive.google.com link and they ask you to put this whole thing inside of it? They're only actually looking for this parameter here, so this file parameter. Everything else here is actually completely unnecessary, and that they're going to likely be using regex to extract this. And if that regex is vulnerable, well, then maybe we can inject some kind of parameters in here, path traversal strings, etc., etc. So really look out for that. If you want to test the regex, you can put something like test.com here, and if it still works, then the regex is probably dodgy. So that's something that you want to look at. Remember that if you manage to inject something here, it probably won't even matter because they're just going to be looking at this parameter. So focus on trying to inject something here. But in our case, the server is just looking for the ID. So we're just going to copy the ID over like here, and then we're going to go here, file ID. Going to press this button here, open this here, and you can see we are viewing purify.js, but we don't have access to it. This is a bit annoying though. I don't know why it keeps signing me in as this one. I try to fix that. Either way, you get the point. This is an iframe to the actual file here, and this is actually taken from, so we put the ID here. This is taken from the Google Drive API. So the server is looking at the WebContentView link here, and it's going to display it here. So this is taken from the Google Drive API. And you can see it also took the name. So it took the name of the file here. I didn't give this the name, so it took that from the API. And now let's look at the request in our HTTP proxy. So let's go to Kaido. Let's just do the same thing again. Click this button, get open, have this here. And let's just send that into the replay tab. So just you can see it, I'm not blocking anything now. Phenomenal. So let's just get that request here. And you can see that it's putting it directly into here. So I remember I said alt/media injection. This is what we need to test for first. When it's a query parameter like this, I like to start off with base 64 encoded, single, just one for now. Maybe we can test double encoding later. If it's a JSON request, which it will often be as well, then I like to actually just put the question mark in, and then later on test if I can do things like URL encoder. So let's start with just a URL encoder parameter. Let's put alt equals parameter media, just like the Google Drive expects. And then let's see what happens. Let's send this in. And something failed. So in terms of this, we get the whole debug because I set it up like that. And it says invalid value media is equal to. So you can see the server is specifying fields out inside of it. We don't really want it to actually look at that. So we're gonna put %.23. This is going to be a hashtag character. So the hashtag character will basically remove everything to the right of it. And it's very handy, especially for hackers, because we can just basically get rid of other input to the right of it, which is very convenient. Some of these features I honestly think are just made for hackers, because like I don't really know like why you would even use some of these things. I have seen this hashtag parameter used before actually in some other websites, but it just feels like something tailored to hackers, like especially this JavaScript URL as well. It's supposed to be something like some weird conspiracy going on at Google, but yeah, we're going to send the hashtag parameter in now. And the server buffered and got an unexpected API response. Well, why is that? Let's have a look at Drive. The file that we're uploading is purify.json. So this is just DOM purify, except that it's in my Drive right now. And the reason it's unexpected is because it's downloading DOM purify and then trying to parse a Google API response. So now the second part of it is to create a malicious JSON response. So we're going to look at this. I like to use something called text editor to actually edit this whenever I have this. So we just go in here and it's going to allow us to edit it in JSON format and then save it dynamically. What we're going to do now is we're going to create our malicious JSON file. And what I tend to start off with is to create an ID. So create an ID of whatever. Then look at what the server is taking from the file and then basically supplement it myself. So in this case, it's taking the name of the file. So we're going to take the name of the file and we're going to say, just put something like test in here for now. And then it's also looking at the web view link. So it's either looking at one of these two things, the web view link or the web content link. So I'm just going to specify both of them. So we're going to say web content link, like so. And then we're going to say web view link, like so. And then we're just going to put like random parameters in there for now. So we're going to save this, and instead of having the server go to purify.js, we're going to share this one, copy the link in here, and then copy this file like so. So we're going to exit that, go back to Google Drive Viewer, and then press this button. Actually, no, we're going to go into Kaido, sorry. Go into Kaido, and then replace this ID parameter here, like this. And let's see what happens. There we have viewing test, and it seems we have the iframe injection as well. Let's go back here. I'm not sure which one it's using, so we're going to use both of these. Now you can see it's been appended directly into the iframe. That's really good news because it means that there's no verification checks going on. So it's not checking whether this is a HTTPS URL. And now we're going to use our second little technique here, which is going to be our JavaScript URL, to hopefully pop an XSS on this. We're going to paste this inside of both, just to be sure. And if we save this and go back into here, and we resend the request, you can see we have a JavaScript alert box. Let's try this in the browser instead to see if it actually pops as well. So we go into Google Drive Viewer, we get rid of that old file ID, like that, and let's see what happens. And we get our alert box popping up. We can check the DOM as well, and we can see we have a JavaScript alert box. Nice. So that's how we can pop a cross-site scripting vulnerability. What's nice about this is that this is going to be often stored as well as that. If the server saves this as a file and then other users get access to this, we can get stored cross-site scripting. So the best one, because then we don't need any sort of URL payloads. So it's really nice if you can get that. That should be almost certainly a high vulnerability, unless there's a content security policy, and if there is, then you're going to have to maybe try and bypass that, and otherwise very good vulnerability there. So that's what you can do if the server is trying to render a client side. If the server is rendering client side, this is one of the vulnerabilities we can look for. What about if the server is doing server side fetches instead? So let's look at upload.php instead. So let's just go here, and I think I've already authorized it. So this application here, we're going to be uploading the file, and it's going to be fetching the thumbnail of the file for us instead. So this is going to be looking more at some kind of Google Drive files. Maybe we can create like some kind of new Google Doc or something just to showcase this. I've created this test document that we can use to just check if the thumbnail display thing actually works. So we'll just go share it. We'll go here, we'll copy the link as usual. So just the file ID, go back to the Drive Viewer, and let's see what happens. So we have this, and it doesn't appear as a thumbnail link. Maybe it's because this is in docs. Not sure why that doesn't work, but it seems like the file name was still fetched. Seems like the file name was fetched, so the API works. Maybe it's my shitty implementation that doesn't work. Whatever. It's what it is. We just pretend that it does work, and instead of that, we'll just go into the file ID, we'll paste it again. We'll go into Kaido, forward the request like so, and then we'll open this like that, and we'll go in here. Let's just send that to a different to the replay tab as well. Alright, TO. So we're in our replay tab. Let's see what happens here. Probably the same response, nothing crazy, and it seems like we don't have a response there. Let's try the exact same thing. Just going here to our, actually let's just grab the payload from the other thing. Let's just grab the payload from here, copy over the file ID again, like so, and then let's see what happens. And we get no thumbnail downloading available, but see the name has now changed. Instead of file test doc, we now have file test. So the nice thing is that it appears to have read the name from here, but there's no thumbnail download link available. So let's do that ourselves. Let's create a thumbnail link here, and let's simply come here, and just for now we'll have it fetching its own domain here, like so. And I've created a file called test.png. This is for testing exactly this kind of thing. Sometimes the server will verify if the MIME type is correct. So we need to make sure that it's actually the correct file type, and then we can start testing other injections. And let's change it to HTTPS as well, actually. So it works like that. Go back into Kaido, same thing as last time. Send this request here, and let's see. It appears like something is actually loaded. So we have a look. So we look at it, and our test.png, which is a thumbnail I copied from Google here, it's been loaded. Nice. So we have some kind of server-side request forgery. We are able to redirect the server to a domain we control. Now, let's test another thing. Can we hit internal IPs? Let's come here, HTTP, and let's simply try and hit some kind of internal IP. I think best thing we'll do is try and hit the Nginx IP. So this is where the website is hosted. And let's see if we can have a look at that. So we'll save it there. Go back to the payload there. And let's see what happens. We get some kind of response. We'll go back into HTML. And we have a broken image. This will sometimes happen because if the image type is not a PNG, and the HTML won't be able to display it. Instead of that, we'll go directly into downloads.png. So let's just go here, go to Kaido again, save it there, and then go to this downloads link. So hopefully Kaido is stopping that request there, here, and then let's see, and we have hello world. So hello world is just the thing that displays on my website here whenever I go into the base page. And we managed to hit that internally. That means that we can hit internal IP addresses, and now we can basically start exploiting the server-side request forgery. So we can start scanning for different IP addresses. We can enumerate internal services. We could look at metadata, which is kind of more secure nowadays, so that we can basically try and escalate this vulnerability to something like a medium, to something like a critical, by finding some kind of exposed internal service. So those are the two vulnerabilities I wanted to demo. You can see that simply by manipulating this API response, we can get the server to do a lot of things. Developers tend to assume that this stuff is safe, content coming from third-party services, especially something like Google, because basically there's a reputation there, like, oh, we don't need to really verify that because it's coming from Google. Like, why would Google be trying to hack us? But they do forget that there is ways to inject our own payloads into it, and this is not just true for Google. There's like hundreds, like thousands of public APIs used by all manner of different companies, and there's ways to do this in basically all of them. So things that they're not aware of, and it's just about basically preventing these vulnerabilities. It's just about securely implementing them, making sure that parameters are URL encoded before they reach an URL, making sure that path traversals are filtered out, making sure there's no secondary path traversal as well. Those are really important things to look at when you're a developer. And honestly, like, not trusting third-party services is okay. It puts a little bit of effort, but it has saved a lot of critical vulnerabilities in the past for websites that were at risk of these things. I hope you enjoyed this video on Google Drive implementations. It's my first video of 2026, so hopefully it gives you just the right amount of information that you can start your year off with a nice, good bounty. If you did enjoy the video, then please do leave a like and subscribe to the channel so you get more book bounty content recommended to you by the YouTube algorithm, giving you that edge over the competition as well. It's also a free way that you can support my work, and it would be greatly appreciated as well. Anyways, thanks for watching and happy hunting. And by the way, no pressure, but if you did enjoy the labs that I made throughout the video, these examples that I always show to you, then you'll probably enjoy the labs that I have in the link in the description of this video. The 12 hands-on practical labs that you can try yourself, and they're all online, so you don't have to download anything.